Welcome, everyone. Hope you're all having a great build this year. Today, we are going to be diving into one of the most critical aspects of running Kubernetes at scale, and that's troubleshooting. This session is all about practical tips and techniques. We'll walk you through some real-world techniques, patterns that we have seen our customers most often encounter, and some of the frequent edge cases as well, and some deep problems that we have seen customers often, again, encounter. At the end of the session, you can expect to walk away with clear mental models, workflows, and structured thinking around how to debug AKS issues. You can expect to know about some of the lesser known tools, but still yet very powerful, that are available in AKS as well as in Azure. And last but not the least, you will also have the confidence in dealing with them. We'll also end with some of the best practices so that you don't have to come to this session next year. With that, let me introduce my esteemed colleagues here. Go ahead.
Hello, I'm Jose. I'm a senior software engineer at the Azure Core Linux team, and I'm one of the maintainers and developer of Inspector Gadget. That is one of the tools that we will demonstrate today.
My name is Wan Li Peng. I'm the engineering manager for the AKS data plane team, responsible for the area of observability.
Hello again, I'm Aritra Ghosh. I'm a senior product manager on the AKS observability team. I work on observability and troubleshooting. Surprise, surprise. Cool. Let's jump in with a two-question poll. And this is probably the longest poll you have had, but please take some time to pull up your phones and take some time to answer the poll. While we do that, I'll also pull up the results. You all still have the poll on the left side of the screen. I'm curious to see what people have on their mind today. Yeah, this is what live loading looks like. Awesome. Looks like you're in the right place. I also want to switch up the screen to look at something else. So it looks like about half this room does something with troubleshooting Kubernetes on a weekly basis. So I hope at the end of this, you'll have to only do this daily or probably never. We'll see. Cool. Very much appreciated. So it looks like we have something for everyone. We are going to discuss about all the different issues that are listed here. So yeah, thanks again. This is our agenda for today. We did the introductions. We'll start with some of the challenges with troubleshooting Kubernetes. We'll focus on three specific scenarios, one on networking issues, one on node health, and one on create, read, update, delete, or CRUD. We'll end with some best practices and announcements. There's lots of exciting announcements interspersed throughout, so definitely stay tuned. We'll hopefully have some time for question and answers and any questions and feedback as well. Cool. Let's take a step back and look at Kubernetes troubleshooting, and what seems like on the surface seems to be easy is not always the case. There's a lot of things underneath which are not always apparent. Sometimes it could be things like complex networking issues, infrastructure, system behavior. In this example, something like a pod being not ready could have so many other things. All this to say that it's not just about reacting to the visible error. It's about having visibility of all the layers below. And sometimes this could be deep and often hidden causes. Sometimes there could be no alerts or even something silent that could be failing. If you want to make it both reliable and cost effective, we have to go below the surface. Just a quick show of hands. If you're using AKS today, how many of you understand or know what kind of architecture you run, or do you have an architecture diagram at your organization? It's really good to hear. So that's one of the first principles of starting. Unless you know what your architecture looks like, how the network flows, and how the traffic looks like, it's not almost possible to troubleshoot. So here we'll be focusing on the challenges that our customers see day in and out. So we want it to be practical, reproducible, common, and relatable. That's all what the session is about. Cool. At this point, I will pass it over to Jose to discuss our first scenario. Thank you.
Thank you, Rita. OK, the first scenario that we will see today is troubleshooting networking. It will be it will be very funny because that's one of the most difficult. In particular, we will focus on DNS and TCP. Why those two? It is because DNS and TCP will be always present every time you use HTTP, gRPC, or most of the high-level protocols. So the other reason why we selected DNS and TCP, it is because it is difficult to debug in Kubernetes, and it is difficult because if you have the possibility, you are managed to SSH into the node, and you try to use standard Linux tools, it will be difficult to understand all this output of the standard tools because there is no way to associate that output to the Kubernetes environment. So those tools, those standard Linux tools are not Kubernetes aware. So even if you manage to run, for instance, TCP for debugging networking issues, TCP dump for debugging networking issues, the TCP dump output will probably not contain the output of all the containers that you are running in that system because they are running a different networking Linux namespace. Or if you manage to run that in one node, then you will need to run it in all the nodes that the communication is involved, and then you will have to manually associate all that output. So it is always difficult to debug those two. And the idea or the goal of the following demos will be to simplify that demo, that part. So the debugging tool that we will be using today is all the information that Kubernetes provides, in particular the logs and Inspector Gadget for real-time debugging. Now let me just briefly introduce Inspector Gadget before we start using it. It is an open source project for troubleshooting, monitoring, and security. It is extensible through a set of tools that we call gadgets. And those gadgets can be used on those three areas. For instance, for troubleshooting, you can use it for real-time debugging, which is what we are going to show today. I'm going to demo today. For monitoring, you can use Inspector Gadget to export custom metrics to build your own Grafana dashboard. It could be the Azure Managed Grafana or open source Grafana, or any other OTel-compatible collector. And the third case will be security, for instance, to create Prometheus alerts with those metrics that you are able to generate using Inspector Gadget. And finally, one of the features that make Inspector Gadget suitable for this session is that it is Kubernetes aware. As I mentioned before, that issue to associating the output with Kubernetes resources, Inspector Gadget do that for you. So every single event that you capture in your system will be enriched, will also contain the information on Kubernetes. So that event happened in that specific container, pod, namespace, and node. So that's an association you will not be able to you don't have to do it yourself. Now, let's go to the demo to make it more clear. So let me switch here. It will be a live demo, so pray for me. So I have an application running in AKS, and I'm exposing it using a ingress manage. So let's get the IP of my application. OK. I'm using HTTP. Please don't do that. Use always the secure way. This is the demo. So we have a very simple store. Here, probably many of you are familiar with this demo because it is an AKS demo. So here we can put some products into the cart. Here you can see the products, remove it, and check out. And here the first issue. So this is a normal application. You are testing your application. You are developing this application. You are testing it, and you encounter that issue. Now, OK, let's start debugging it. But before I start debugging, let me show you the architecture of the application. So we are exposing our application with an ingress. That is the one I get the IP before. The IP before, not version 4. And this is the application this is the service that is building the front end. It will just get all the requests, and then it will build the website together with the product service. That is the one with the list of the products. And every time we click on checkout, the order will be sent to this service. And to simulate that is handling the service, it is just putting it into a queue. And for some particular items, it will need to count an external endpoint. We will go back to that in a moment. Now, our suggestion is to always divide your environment into parts before starting troubleshooting. So we are exposing our application using an ingress, and this is the first part, the entry point for our application. So let's focus on this first part to try to troubleshoot this situation. So let's back to the code, the terminal. So now, we will be focusing, we said that we will be focusing on the very first part, so the storefront. So let's check the logs of the storefront. And when we go here it is, okay, we get this error. In the logs, we are seeing that we have a connect, that the connection get refused. And this is an IP of a client. The connection was refused, connected to an upstream. Upstream is in here, and this is the client. So let's say that the most useful information from here is that we are getting a connect. We see some IPs, the source, the destination, but it is difficult to correlate this information to the actual Kubernetes resources. So my suggestion is to use an easier approach. It will be using Inspector Gadget. So let's start by installing the client of Inspector Gadget. You can use Crew. It will install a kubectl plugin and now deploy it into the cluster. Okay, we have now Inspector Gadget running into the cluster. And given that we saw that it was a connection failure, so we will use the trace TCP gadget. It is a gadget that will allow you to trace all the TCP events happening in your cluster. But we don't want to see all the cluster because we fragmented all it to just focus on the part that we are interested. So the IG demo namespace where our application is running, and the store front end to select the pod that is managing the front end. Okay, and let's reproduce the issue again. Check out here. So we have the first event. Inspector Gadget captured the first event. It is an accept, so we have the storefront that is accepting a TCP connection from the app routing system. This is the ingress that we are using to expose the application. So we first accept the communication, the connect from outside to our application, and then we have this second one, that is the connect from the storefront is trying to connect to the order service, and it is and this connection is the refuse that we saw in the logs. So look at how different and clear the output is. From this time we have the service that is receiving the connection service, the namespace where it is running, and we have here the pod that performed the connection. So, so this is what we have. Let me show you this. So this is what we have right now. We saw that the communication between the storefront and the order service is the one that is failing. So let's check the order service, the logs of the order service. Done. So let me run the logs. This command. So we are getting now the logs of the order service. And we only have one log that is serving, that it is listening. So probably it is because it's not receiving any connection request, or there is something that is going wrong, and we are not logging that connection. So now let me show you what the situation that we have. Oops, let's do like this. Sorry. Okay, now the scroll working in a strange way. Anyway, we have it here. So we are seeing that we received the service. The storefront is trying to connect to the service, but we know how the service works. The service will try to forward that request to the pod, and the pod will be in that particular container pod. So let's check our YAML to verify that's what is happening. If I run this, okay. So we have here the service, the definition of the service. With the target port this is the target port. Let me put the definition of the container in here. This is the order service deployment, and we have here. So, oops. Look that the container port and the target port, they should match because this is the port that the service will try to connect. So we have identified our first issue. This is let's see how it looks. So we see that we have a mismatch between the service target port and the container port. This was just for an example of an issue you can run when you are developing your application. So let's fix it. So I close it here. Let's fix it. Okay. And now let's apply again. Okay. The new YAML should be running now. Just check everything. Okay, everything is running. It's running. And check out. Everything fine now. It was just a mismatch in that. But the important part is how to, the solution was pretty easy, but the important part is how to arrive to isolate that issue, how to identify that issue, that TCP issue. Okay, now back to the slides. Okay, the second part of the demo will be focused on DNS. These are the components that are involved in a DNS resolution, the kubedns and the upstream DNS only for particular cases. So we have two cases. The first one is when you are trying to resolve, for example, another service. This host name, it will be managed by the kubedns service, and you will be able to connect. But if you want to connect to an external endpoint, then the upstream DNS, which could be the Azure DNS or a custom DNS that you configure, will be involved. So let's try now the DNS demo. So back to our application. Everything is working fine, but let's add this particular product that we have here. And check out. Yep. Okay. Now we have a second issue. So let's try to debug this part, this second part. So the part that we are debugging? We receive the order. The order, that's the particular item that I mentioned at the beginning, that for processing that order, it needs to contact an external endpoint, the order with the Inspector Gadget product. And so let's focus on this part, on the order service. Let me close here, and let's check again the logs of the order service that were empty before. Okay, like this. Let me clean up for you. So here we have the issue. Look, connecting to internet failed. That's pretty much clear what the issue is. It is trying to resolve myexternalendpoint.com, and it's getting an error trying to do that. So given that this is a DNS issue, we will be using the DNS gadget. But before doing that, as I mentioned, let's try always to focus on one part at a time, and this is the first part that we will analyze, the communication between the order service and the kubedns service. To do that, we will be using the Inspector Gadget Trace DNS. Okay, so we are running now Trace DNS instead of Trace TCP. Again, filtering by our namespace. The selector this time will be for the application that is performing the DNS resolution. And look at this particular filter. We already know that we want to know this URL that is being resolved. And these are just the fields that we will print. So reproduce the issue again. Check out. It takes some time. Okay, and we are capturing all the DNS traffic that is happening in our cluster, but after this filter. So we can see that the order service is performing a DNS request towards the kubedns with this name. We have the queries, several queries were sent, and here are the responses with server failure. Trust me, it is failure. So what we have here is that, okay, the order service is trying to resolve this URL, and it's getting always the error. But remember that when we are resolving an external URL, also the upstream DNS will be involved. So let's check if that failure is coming from the upstream DNS or it is the kube DNS that is responding with that error. So to do that, we will simply change the filter that we are using. And look at this time, we are not in our namespace in IG demo, but we are in the kube system namespace and using the labels of the kube DNS. And again, here we are filtering by the name, the URL that we are interested, but this is the IP of the custom DNS. So for this demo, I configure my AKS cluster to use a custom DNS that we know that is something that people do. And let's reproduce the issue again. It takes some time, a couple of seconds. Let's go. OK, now, so we are checking out the communication between the kube DNS and the upstream DNS. And we saw several queries, but no responses at all, or different IDs. So these IDs are different queries, but we are not getting any response. So we were able to isolate the issue. We know that now is the upstream DNS that is not responding, and the kube DNS is generating itself a response with the server failure that we saw before. Now, the question is the upstream DNS not working at all, or it is just a wrong configuration, what is happening? So to do that, this is a way to verify the general health of the upstream DNS. So this time we are, again, filtering by the kube DNS, but we remove the filter of the specific URL. We are just seeing all the traffic between the kube DNS and the upstream DNS to try to identify the health of the upstream DNS. And this is the output that we are getting. Let me reproduce again the issue. No. OK, so what we see here? We see several queries and responses. Oops. Let me put this like this. OK. So we have queries, and here are some responses for this. For instance, for this dot. This dot is just a health check that the kube DNS does with the upstream DNS. So what we can see here is that we have some queries that are going to upstream. The upstream is actually responding for some of them. So we can say that the upstream DNS is running, but for some particular reason, it is not answering to those myexternalendpoint.com. So this is what we have, queries, but for others, queries like the dot and micros.com that was also there, you will see queries and also their response. So we were able to identify that the issue is not just it's not that the upstream DNS is down completely, but for some particular queries, it is failing. This is the worst case scenario that you can encounter, that you need to troubleshoot in real time an issue. But the idea is that you try to instrument your system to identify those issues proactively, so monitoring. So for instance, you could use Inspector Gadget also to create a custom metric that create this metric that tell you every time there is a failure, a response failure from the upstream DNS. So you could just in advance know that, OK, something happened in my class, something happened in my custom DNS, and the queries the responses with an error are increasing. And you probably will be able to anticipate those. And yes, that's all for the demo. Let's back to the slides. So some takeaways from those two demos. So first is remember what we did. We divided our environment. We focused on the entry point, then check the log, then all the communication with the other components. Then if one is broken, we focus on that part and go and continue in that way. For the tools and data, the logs are pretty good point to start with the analysis. But then once you know, okay, this is a connection error or this is a DNS error, let's dive in using a dedicated tool like Inspector Gadget. We will provide you this real-time troubleshooting of generating metrics. And we demonstrated today just the networking part, but Inspector Gadget can be also used for security, for performance, for instance, to see what are the pods or the containers that are consuming the most resources. As an alternative, if you want to focus on just metrics and logs related to networking, and you want to support also Windows, we definitely suggest you to check the advanced container networking solutions, services, and last part, we just demonstrated a set of features that Inspector Gadget has, and it has a lot of more, so I invite you to visit the website to check them. And said that, let's pass to the second scenario. Wally, all yours.
Thank you, Jose. Great demo. All right. If you've ever spent several hours debugging your application only to find out that the node was not ready, I will show you how I debug these kinds of node health issues. So next time you can be more like the guy on the left, cool, calm, and relaxed. So with all the different metrics and logs that our applications, AKS, Azure, emits, it can be confusing to know where to start to debug these kinds of issues. So I'll go over a few key areas that I always look at when I'm debugging one of these issues so that we can help you guys find the root cause of your problems. So the first place that I always look when I get paged for a node not ready issue are node conditions. Usually I'll just pop open kubectl, describe node, or go to our portal experience, which has the same information. And I'll look for node conditions that are failing. So in addition to the node not ready condition, I'll also look at other conditions to see if those will give me a hint at what might be going wrong. So in addition to the built-in Kubernetes node conditions, AKS also installs Node Problem Detector. Node Problem Detector extends the set of detectors beyond what's built in Kubernetes to offer detectors around resource pressure, scheduled events, as well as other common system issues. Now, node conditions don't always have answers to all your problems straight away. So we're adding a new node not ready diagnostic condition that will give us more information about what is actually failing on the node when the node goes not ready. In particular, we plan to show basically top offenders when it comes to CPU, memory, I/O, networking, so that we can point you in the right direction so that you can know what to fix. So let's go through a couple of node conditions, in particular disk pressure and memory pressure, and talk about what to do when we see these things. So first of all, disk pressure is talking about the storage available on your node. So it's a signal that tells you that you have very little free space left. So if I see this condition, the first thing that I'll do is I'll do another kubectl describe node, and I'll look at the node condition for any details, plus I'll look at any events related to disk space. One of the common failures is garbage collection, container image garbage collection not being able to run. Now, that's not always going to be the problem that you encounter. So sometimes you'll have to dig a little bit deeper. You might have to do kubectl node shell or even SSH to the node to get more information about what's consuming all the storage. So you might have to jump on there, run du, df, several utilities to understand what's going on. Now, what do you do once you understand what the problem is? Well, because it's related to disk space, you have a couple of different options. One would be, okay, clean up the files that are consuming all the storage that you didn't expect. Another one would be figure out why the container image garbage collection isn't running. And of course, there's also always the option of being able to choose a larger disk to have more capacity. Now let's talk a little bit about memory pressure. So again, I would go to the run kubectl describe node, see if there are further details about what might be causing the memory pressure on the node. Some of those indications might be kill events. You might see a particular pod get killed, and you might not understand why. That's where you want to run some tools like kubectl top pod, and maybe even look at some metrics, which I'll talk about a little bit later. Once you understand why you're having memory pressure issues, generally the thing that you're going to want to do is adjust requests and limits for pods to make sure that your pod is not overcommitted. And of course, there's always the easy out, which might be to choose a larger VM size. Okay, so what happens if the issue that you're debugging isn't actively reproing? This is a common problem. Well, the good news is that all of the node conditions we just talked about are also emitted as Kubernetes events. And so that allows you to be able to view those events and those node condition state transitions happening on a timeline so that you can understand the sequence of events that might be leading to the problem that you're observing. So for example, if you're debugging a pod readiness issue, you might go look at Kubernetes events and see what was happening right before the pod readiness event started to fail. And you might find that there's a memory pressure condition or even a disk pressure condition that might be causing that pod to fail those readiness probes. And so again, Kubernetes node events are very helpful in this situation and also allow you to kind of time travel back and be able to see what happened earlier. Okay, so now if you've been debugging your application and you have not been able to find what's going on from the node conditions or even the node events, you might have to go and look at node metrics. In particular, there are a couple kinds of failure modes that you won't necessarily be able to figure out with events and conditions alone. In particular, I/O-related issues and networking-related issues having to do with throughput. So that's where you would come to one of these dashboards to try to understand if you're hitting an I/O limit or a networking limit. And generally, you might see, on one of these graphs, one of these metrics get pegged at a particular level and not be able to go beyond that. That's generally indicative of you hitting some sort of throughput limit, which might lead to some of the failures, readiness, or something else that you might be running into. There are a few places today that you can go and view these. One is in the Azure portal in the node view, and then another is in Azure Managed Grafana. There's a node dashboard there. So today we're announcing a new option to be able to view these metrics, which is the Azure Monitor Dashboards with Grafana. What this is Grafana embedded right into the Azure portal. If you're a fan of Grafana, it still allows you to customize dashboards and reference any number of kind of Azure-sourced metrics. And so if you're not already a user of the Manage Grafana option, this is a fantastic option, which is also free. So this is in preview today. All right, so you might be wondering, if you had a node go not ready and had these problems and you didn't take action, what happens? That's where AKS Node Auto Repair kicks in. So we're trying to make sure that you have a good experience on AKS, and so we try to repair nodes for you in the event that nodes go not ready and they're not fixed. And so what we'll do is, after 10 minutes of a node being in a not ready state, we will start to perform an escalating set of remediations. So first, we will go and attempt to reboot the node. If that fixes the issue, great. If it doesn't, we'll then jump to re-imaging the node. If that fixes the problem, great, we're all good. But if that doesn't work, then we will go ahead and redeploy the node to a different Azure host. Now, if you see that Node Auto Repair is kicking in very frequently on your cluster, that's usually a signal of a larger problem and somewhere where you would want to go and do the steps that I talked about before, diagnose, understand the problem, fix those issues, because really, Node Auto Repair is the last line of defense and not something you should generally rely on to keep your service healthy. So sometimes, the things that, the debug steps that I mentioned are usually able to get you pretty close to the root cause of what's causing your application issues, but not always. In some cases, you might have to dig deeper to figure out the root cause. Sometimes you might have to look into pod metrics, pod logs, kubelet or container runtime logs. Sometimes there's some critical piece of information that you'll be able to find there to root cause the issue. Earlier, I also talked about something called the node not ready diagnostics. When that's available, the output of that tool will be available in the Diagnose and Solve section in the Azure portal. So you can always go there to get more information about what might be failing. And our hope is that this Diagnose and Solve detector will tell you all the information that you need. All right, with all that, I will hand it off to Aritra to give the Node Health demo and go over some of the techniques we talked about.
Thanks, Manly. Cool, now let's put it all together into a demo. Here we have some of the developers reporting that they see high error rates on one of the production apps. They see that the latency is like on some of the calls are high, and we want to figure out what's going on. Particularly, we'll also show how we use application insights here. Turns out that we have auto-instrumented the code. What that means is without adding any custom instrumentation, we have all of the traces, metrics, and logs from the app layer. So one of the suggestions here is always start from the debugging from the point of applications and from SLOs, and then go down to whatever could be the root cause. It could be at the app layer, it could be the infra layer, but it's important to start at the apps. Cool. Here I am starting again from the application insights. I see that there's a high number of failed requests, so something seems strange. I can see the server requests have spiked as well. I'll head on over to the application map. This tells me all the structure of the microservices and how they interact. I have a simple three microservices, A, B, C, A calling B, calling C. I see that there is, again, like some calls failing specifically on service B. And I can see some notifications. Essentially, those are alerts, and some of those are auto alerts as well. You don't have to configure them. From here, I want to figure out what pod it could be running on. So this automatically associates with the pod in AKS. So from the application instance, we move to the AKS layer, which pod, which node. I want to just rule out that it might be on a node which is faulty. I see that the pod has some warnings. I'll take a note of the node here. This is how you find the node on which it was running. And I'll head on over to the nodes tab to figure out what's going on. Now we'll put off all what Juanli said into action. I want to first start with looking at the node conditions. You can all, again, if you're familiar with kubectl and CLI, you can use that. If you're in Portal, you can start with there. So I'll start with the node conditions first. And you can already see the node is not ready. That tells me that the issue is something with the node being not ready. But we also want to go further and figure out why was the node not ready. We can see that the kubelet was stopped posting status, which tells us, yeah, like that's why the node was possibly not ready. You will also see the other node conditions appear, the ones about node problem detector we discussed earlier. I'll next go to the events to see like what events were on the node. You can already see there was some node reboot restart. So these are the remediation events we talked about, the auto repair events. So it looks like the node was not ready before and like remediation was also performed. Now this is where it's interesting. I'll also want to show one other place to start troubleshooting, which is the new monitor TOC. This brings together all of the insights from the cluster. It's the single pane of glass view which brings all of the insights from the pods, logs, nodes all together. It also has some of the infrastructure metrics which go beyond AKS itself. So this is a good place to start. I just brought it up to show where you could start. I'll head on over to the managed Grafana, which talked about. You can see this is specifically shows the usage by pod. You can see one of the pods spiking, the CPU usage spiking. Similarly, you can see the memory. And these dashboards, again, are there by default. You don't have to do anything. I added one of the visualizations. Just tell me that the node was not ready, something. And you can add this both here and it's something which I'll show later as well. This is where, again, the exciting feature which Juanli talked about, dashboards with Grafana. You don't have to go outside Portal. You have all of these dashboards. You can add more. I'll show exactly the same things inside Portal. Again, I'll filter to the node we saw before, which was not ready. And again, you see exactly the same views that you saw there. So you don't have to go back and forth. You can stay here and get all the richness, add, edit dashboards as per your requirements. This was one of the dashboards. There's other dashboards to show. One more on Node Exporter, which is, again, one of the default dashboards. You can look at things from a node level there. Hope this was useful. We'll move on to the next section. Awesome. The last scenario for the day we have on our mind is CRUD. In the process of operating AKS clusters, you will often have to add new applications, maybe upgrade your cluster, upgrade your node images, maybe delete some resources, and all of this is basically CRUD. So often you might encounter cases where one of these operations doesn't go through. That's when you say that the cluster node pull out that operation was in a failed state. And we'll go through 2 or 3 tools which are both handy, very easy to use for these cases. So the first one is the failed cluster or node pool. The first thing I want to point out is a cluster or a node pool in failed state by itself does not indicate the health of the cluster. All that means is the last operation on that specific resource failed. This just helps because sometimes it can be particularly panicky if you hear that, yeah, something has failed. All this means is like the last operation failed. Most often we see this happening on upgrades. You would want to use all the richness of new Kubernetes versions and like keep upgrading, and sometimes they fail because of various reasons. Here, I want to call out something that we have now both available in Portal and AKS API. This is now GA, which is the last operation status. So you don't have to worry and go through several hoops to get this. You will find this both in Portal and the API, which has exactly what failed and what the error was, including the troubleshooting guide. This is like you can go through just on the overview page and also show it in other places where it's available. The second one is now we know what was the failure cause, but we don't know what triggered it. What was the operation that triggered? In many of these cases, it could be something that was orchestrated, something that was not done by a human. So these are 2 avenues to start with. One, activity logs. Typically, anything in Azure, any operation you perform is logged. and that has the specific operation and the status of the operation as well. In the case of upgrades, now we have all of the auto upgrades logged in Azure Resource Graph. There's no opt-in. You have all of the upgrades here, record of upgrades here, without having to like enroll in another feature. You can also set up upgrade alerts on these, which I'll talk about again later. The last thing I want to point out is you can do this both for node image upgrades, Kubernetes version upgrades. So it's helpful for all different kinds of upgrades. That brings us to the demo. Pretty simple demo here. I was trying to scale one of my node pools, and the scale operation failed. And I'm trying to figure out what happened. I'll be using Portal and Azure Resource Graph, and also a little bit of Copilot. Cool. I start with again the cluster overview page. You can see that the cluster is in succeeded status. If it was failed, you could see why it was failed. I want to just make sure node pools are OK. Head on over to the node pools page. You can see that one of the node pools is in failed state. Just as you click on it, let it load up. And this is also available in the get manage cluster or the get node pool API. You can see a very clear error message which tells me why the node drain failed, tells me what pod wasn't able to be drained, has a troubleshooting guide, and also has the specific pod disruption budgets that failed. So this by itself gives me a very good idea of what's going on. Now I'll show the same thing and what could have caused it from Azure Resource Graph. You don't have to worry about the query itself. It's in the docs. But essentially, it shows a history of all the upgrades on the cluster. I can see the Node OS upgrades, the Kubernetes upgrades, and you can particularly see one of the node upgrades has failed. That is why the node pool is in the failed state. Now here we'll go one step further and actually try to fix this and understand, like, yeah, why did that specific PDB or Nginx deployment fail to be drained? Yeah, this is just to show again like the same things. Yeah, I'm showing here one version of the Copilot using the run command. There's different ways. If you're like me who doesn't know simple kubectl commands, you can use the Copilot. So I'm just going to get the list of PDBs in the cluster and use Copilot to draft the query. This works both for complex and simple scenarios. But yeah, so this will give me a list of pod disruption budgets. While it pulls it up, the next thing we want to do is we want to see what were the pods running and find where the mismatches, why we were not able to satisfy the PDBs. So we can see that the Nginx has min available set to 2 at the top. Yep, so you can see that 2. And now we want to figure out how many Nginx replicas were running that caused it to be failed to evict. Same here, I'm going to use Copilot again. And you can also see there's a dry run mode. So you could do the same thing and just see what command it gets without running it. You can see that there's just one replica of the Nginx pod running. So here there's 2 different fixes. You could either fix the PDB to make it less restrictive or increase the number of replicas of Nginx. Whichever way you can get to fix it. So this just goes end to end of like starting from the node pool was in the failed state, figuring out what was the reason, going to Azure Resource Graph, and then fixing it. Awesome. Wouldn't it have been good if you didn't have to attend this session altogether? So here are some best practices I specifically want to call out. So you can see that it's important to have the right sizing of your nodes. Make sure your cluster operations are like good, which is setting the right PDBs. Make sure your network is resilient, and also, well, most importantly, configure monitoring for all of these things. Also, note that now the Azure Monitor Prometheus recommended alerts are now GA. This is a set of pre-configured alerts where you don't have to like add just this is a one-click, single-click enablement, and has all the best practices of the things that we have seen in our customers. Yeah, at this point, I'd like to call on my colleagues back again here. Thank you all. These are a list of our upcoming table talks, some of the sessions, and most importantly, we would encourage you to collaborate with us on both Inspector Gadget, Node Problem Detector, and other projects. We are happy to take any questions, feedback that you have. Is there anything in mind?
I think one question is coming. Yeah, one question is coming.
Of course.
Yeah, hi. So I had a question. In the first demo, I was curious how you were getting, so it looked like you had to set up like basically an e-commerce store setup. And when you clicked add to cart, it was like throwing like a little console pop up.
Yeah.
So my assumption would be is that error was happening client side. How are you getting that error in the Kubernetes pods? Or was it reverse proxying back to the server and handling that call server side?
Yeah, actually the error was generating, the error was happening in the cluster and everything was sent back as a HTTP response, the HTTP response. So in the client just was transforming the HTTP response as an alert.
Okay.
But the error was happening in the cluster. That's what I was able to.
That was where my confusion was.
Yeah.
Thank you.
Thank you.
Any other questions or feedback?
Yeah.
Yes, please.
Yeah, sure.
I just wanted to clarify the in ADO, the support for Grafana dashboards. How integrated is that? Can you provision Grafana dashboards from there, or is it just for existing dashboards you can see outputs?
Great question. And this was for the dashboards inside Azure portal, correct? Yes. So you can add your own custom dashboards there as well. You can bring in new dashboards. You can edit the existing ones, which gets saved as a new resource.
Okay.
As long as the data sources are based in Azure, which is either Log Analytics,
Okay.
Azure Native Metrics, Prometheus Metrics, Application Insights, and ADX, Azure Data Explorer, you can do any of it. If you have requirements for things that span outside of those or automations, then you will still need Azure Managed Grafana.
Okay. And if you provision some of those resources in the Azure portal for those dashboards that are using Azure-based metrics, can you see that stuff show up in Grafana as well if you go to the Grafana portal? Or is it exclusively ADO?
I think it's exclusively there. So if you want that, you'll still have to export that to JSON and then use it in Azure Managed Grafana.
Okay,
But it's a
thanks.
good question.
Thank you. Thank you. That's all.
For the people in the room, if you want to sign up, we have a question and we have a book, the Kubernetes Best Practices, which is signed by Brendan Burns, is one of the authors. Maybe you want to ask a question on Inspector Gadget?
Name one Inspector Gadget.
Yeah, name one of the gadgets that we used in the demo. Awesome. Come on, Ed.
Winner, winner.
It was like competition, guys. Appreciate some good topics today.
Awesome. Thank you.
Thank
for
you.
Feedback and yeah, here you go.
All right. Thanks, guys. Thank you.
Thank you.